Conversion of a galvanometer into an ammeter. A galvanometer is a device used to detect the flow of current in an electrical circuit. Even though the deflection is directly proportional to the current, the galvanometer scale is not marked in ampere. Being a very sensitive instrument, a large current cannot be passed through the galvanometer as it may damage the coil. However, a galvanometer is converted into an ammeter by connecting a lower resistance in parallel with it. As a result, when large current flows in a circuit, only a small fraction of the current passes through the galvanometer and the remaining larger portion of the current passes through the low resistance. The low resistance connected in parallel with the galvanometer is called shunt resistance. The scale is marked in ampere. The value of shunt resistance depends on the fraction of the total current required to be passed through the galvanometer. Let Ig be the maximum current that can be passed through the galvanometer. The current Ig will give full-scale deflection in the galvanometer. Galvanometer resistance is equal to G. Shunt resistance is equal to S. Current in the circuit is equal to I. Current through the shunt resistance is equal to Is is equal to I minus Ig. Since the galvanometer and shunt resistance are parallel, potential is common. Ig into G is equal to I minus Ig into S. S is equal to G into Ig divided by I minus Ig. The shunt resistance is very small because Ig is only a fraction of I. The effective resistance of the ammeter Ra is G in parallel with S. 1 by Ra is equal to 1 by G plus 1 by S. Ra is equal to Gs by G plus S. Ra is very low, and this explains why an ammeter should be connected in series. When connected in series, the ammeter does not appreciably change the resistance and current in the circuit. Hence, an ideal ammeter is one which has zero resistance.